Okay, guys, in this lesson, we're going to learn how to solve and graph inequalities with a single variable. We will also look at compound inequalities and some new notation and how to write our solution set. So let's do a quick refresher of the inequality symbols. And remember, we're going to read from left to right. So this first one says A is greater than B. The inequality is open to the A, so it's greater. Then we have A is less than, and when the inequality is pointing toward the value or the variable, that means less than. And then on the next two, you see that they have included part of the equal sign. So this means A is greater than B or A is equal to B. Then we move to the next one, and this is A is less than B or A is equal to B. And this last means A is not equal to B. So one important rule that we need to remember when we're solving inequalities is when you multiply or divide, when you're solving and you have to multiply or divide by a negative number, we will be flipping or reversing the inequality symbol. So as we solve linear inequalities, we're going to do the exact same process as when we solve linear equations. But we have to remember that we are going to be reversing the inequality symbol only when we're multiplying and dividing by a negative value. So please make sure you get that in your notes. Now, let's see why this is. Here we have a simple inequality statement that says 3 is less than 7. We all agree that that is true. But what happens if we were to multiply both sides by -1? We're going to get -3 is less than -7. And let's change this pen color right quick. So we have -3 is less than -7. And we know that is not true. So how can we make this statement true? Well, we can reverse the inequality, and it's going to read -3 is greater than -7. Now, this is true. So this is why that we must always reverse our inequality symbol when multiplying by a negative value or dividing by a negative value. So now let's get into the symbols for when we do graph. And when we have x is greater or x is less, this means that the value 0 in this example is not included. It's not part of the solution set. So in our first one, we have x is greater than 0. So all the numbers that start at 0 but do not include 0 will make our statement true. So I could pick any of these numbers, and you can see the arrow, it continues forever. So if I picked the value 4, 4 is greater than 0. We can see that is true. And then we have x is less than 0. So all the numbers from 0 and left on this number line will make this true, but not including the 0. So if I were to pick -2, we all agree -2 is less than 0. So when we have an open circle, it means that the value is not part of our solution set. And then when we have a closed circle, then we know that the value given is part of the solution set. So this means x, my solutions, is equal to 0, so we're including 0, or is greater than 0. So any of these values, so if I put in 0 for x, if I picked this value that's shaded, we can see 0 is equal to 0. Or we could pick 3. 3 is greater than 0. So I'll use that part to make that true. And then the same goes for x is less than or equal to 0. So with a closed circle, that means that value is included with our solution set. And remember, guys, with inequalities, a lot of times when the arrow is going left or right, we're going to have infinite solutions. Now, that won't be true when we get to compound. So let's take a look at some new notation. Now, we all know how to use the notation x is greater than 0 or x is greater or equal to 0. But let's take a look at the new notation here. So this is called set builder notation, and it looks a little complicated, but once you get used to it, it's quite easy. So let's read this. So the set of x's, so this bracket here, this French curly bracket means the set of, and then we have the x's, so this part is right here. The set of x's, x being an element, so that's what this notation means, element. The set of x's, x being an element of the real number, so this is our notation. So if we note back from when we did our rational and irrational, we took a look at this symbol of the real number. So all the numbers, so my x values are coming from the real number set such that, so this means such that x is greater than 0. So all this is saying is the number, my values of x are coming from the real number system, and my solution set is greater than 0. So you can see all you do is put this part in the end of set builder notation. And then over here, we have the set of x's, x being an element of the real number system such that x is greater or equal to 0. So again, this part just goes right here in the end for set builder notation. Now let's take a look at interval notation. So interval notation is very easy. We're either going to be using parentheses or we're going to use brackets. And I do prefer interval notation. It's much quicker to write. So here we know x is greater than 0, but it does not include. So I like to just start and maybe do it on the number line. So from here all the way, and we see this is going forever in the infinite direction. So I'm going to put the infinity sign. And the reason I'm going to use, so here's all my solutions from 0, but not including, so parentheses, not including, and then all the way forever and ever, because it's going infinite, we have our arrow. And when we use the infinity symbol, you never use a bracket, we use parentheses, because you never can enclose infinity. It keeps going, so you're not going to use a bracket. So that's why we have parentheses on the left, because 0 is not included. And the reason we have parentheses on the right is because it's infinity. Our arrow is going forever in the positive direction. It's increasing. And so we just say 0, comma, infinity. This is not an ordered pair, guys. So I can see this, and without even having this in front of me or the graph, I could say, oh, okay, well, the solution set starts at 0, but it's not including 0, and then it goes on forever. And again, we will always use parentheses when we're using infinity. Now let's take a look at one where 0 is part. So here, I'm starting at 0, and I'm going forever and ever to infinity, and we can never include infinity, so we're going to use a parentheses. So the reason we're using the bracket here is because 0 is part of our solution set. It's closed, and then we have infinity, and that's why we use the parentheses. We can never enclose. And again, we're going to go from left to right as we write these. And on this end, you're writing the least number it can be, and then on the right side of your notation, the greatest number that it can be. So brackets you should associate with the equal because that's included, and we call that closed. And then when we use parentheses, you are associating with the not equal part, just the less than or greater than, and that's the open. Okay, let's get started and solve, and we're going to solve just like we do with equations, and then we're going to graph, and then we're going to practice writing in set builder and interval notation. So remember when solving, if you have parentheses, we have to use the distributive property. We're going to subtract 6 from both sides, subtraction property of equality. And then we're dividing by a positive number, so we do not need to reverse. And we get x is less than -9. Now, I have a -9 is my boundary number, but that does not mean that I'm going to be flipping it. I divided by positive, so we leave the inequality the way it is. So when I ask folks to graph these, I just want 3 numbers. The number we're considering, the number to the left of this -9, which is -10, and then the number to the right. Okay, so we know that x is less than -9. -9 is not part, so we're going to have an open, and then everything to the left. So we're going to shade this way. Okay, now let's do set builder notation. So we're French curly brackets, do the best you can as you can. X is an element of the real number, so it's just like a double line, such that, and then now we just drop this inequality right here. X is less than -9. French curly bracket. That's it, guys. Okay, interval notation. I want to change the color right quick to show this. So interval notation this time, and it's always nice to put these, the infinity. So this time we're going forever left on the number line. And so remember when we use the infinity, we never can include it. Okay, so I'm going to use a bracket, and then we're starting here at -9. And we're not including it, so we're doing parentheses. So my interval notation is going to be -infinity, comma, -9 in both parentheses. So we're going to have -infinity, comma, -9. It lines up just like we have here. Remember, you're going to always put the least value on the left and the greatest value on the right, and you read from left to right. Okay, let's try another one. We're going to add 8 to both sides. We're going to bring x divided by 3 down. We have -2. Now, to undo our division, we're going to multiply. So the multiplication property of equality by 3 on each side. Again, this is a +3, so I'm not going to reverse. And I get -6. So we have -6, and then to the left, we have -7, and then to the right, we have -5. X is greater than -6, or x is equal to -6. So it's both. So I'm going to close it up. So -6 is included, and then it's greater than. So we're going to shade to the right. So any of these values to infinity will make this statement true if we were to plug it in here and work it out. And then let's just go ahead and put the -infinity here. Okay, set builder, guys. So x is an element of the real number system. So all my values of x are going to come from the real number system such that, and the only ones we're going to consider are those that are equal or greater than -6. Okay, let's switch out colors again so that we can see this show up here. So our interval notation, we're going to start here and we're going to go to here. Now this time, -6 is included, so we use a bracket, and it's going forever to the right, so we use parentheses because we can never include infinity. So we have bracket, and again, you're just going to line it up here. My least number that I'm considering is -6, and then it's going forever to the right, infinity, and we use parentheses. Okay, number 3, we're going to distribute first. We get -2x plus +6 is greater or equal to 12. We're going to subtract 6. So the subtraction property of equality, we get 6 here. Now look, so I'm going to star this. I am dividing by a negative, so we have to remember to reverse, and we're going to get x is less than, excuse me, less than or equal to -3. So we had to flip it because we were dividing by a negative. So we're going to consider -3. We have -4 and -2. My solution set includes, so it's closed, and everything to the left, shading, and it's going toward -infinity. Go ahead and put my +infinity here. And set builder. That is not very pretty, but that's okay. X is going to come from is an element from the real number system such that x is less than or equal to -3. And now let's do our interval notation. So again, we're going to use parentheses because we're talking about negative infinity. And then we are going to include the -3. So we're just going to bring this down. This is interval notation. My least number is negative infinity, and it can go up to -3 and included. So not too bad. Okay, number 4, we're going to subtract. So the subtraction property of equality, bring down x divided by -2 is less than, we get -3 here. Again, I want to star this one because we are multiplying both sides by -2. I'm going to reverse the inequality, and then this gives me a +6. So let's graph. We're considering the value 6, and then we have 5, and then we have 7. So x is greater than 6. So 6 is not part of our solution set, so it's going to be open, and we're going to shade everything to the right, and that's going to the positive infinity. And as set builder, trying to get a little better there, x is an element of the real number system such that x has to be greater than 6. And then let's see if this purple shows up. So here we're going to start here. Again, we're always doing from left to right. So x is not part, so I'm going to use bracket. And then we're going to infinity, and we can never include it. So we simply have 6, infinity.